Testing, 1, 2, 3. Testing, 1, 2, 3. We're going live for the ASRG CAN bus intro to hands-on CAN bus and intro to InVehicle Networks webinar. It's a little bit early, so we're not going to start just yet, but I just wanted to get the stream running and just ask if there's anyone in the chat who can give me some feedback. If there's anyone who can let me know that we're live, that you can hear me, that the volume isn't too low, too high. I'm happy to make any adjustments before things get started with the actual content of the presentation. Is there anyone there who can give me any feedback in the chat room, the live YouTube chat? We've got Abdullah Ali saying we can hear me. Okay, wonderful, wonderful, awesome. You love to see it. Okay, so I'll just go ahead and wait a little bit. We'll be starting 1 o'clock sharp. The agenda for today is mostly going to be hands-on. So I'm going to be doing a quick run-through on an introduction to InVehicle Networks and CAN bus. And then we're going to spend about half an hour, 40 minutes talking about actual tools that are available for use, mainly the CANutils package. They're free. They're available to anyone. You don't need any hardware to use them, and that's why I think it's worthwhile for everyone interested in automotive security to learn about these tools. So you guys are early, so you're getting a little bit of a sneak peek into what's going to be happening today. So we'll just give it a couple more minutes. I think people should start to be rolling in now. We will be taking questions throughout the duration of the presentation, but I'll probably be saving some time towards the end to answer those questions as opposed to answering them during the actual presentation. There is a bit of delay between the messages you send in the chat room and my reception of them. This is just the way things work. It's how the internet is kind of built up, right? We have a small delay between streaming services from the streamer side and the viewer side, so please forgive me if it seems like I'm not answering any of your questions. It's not because I'm ignoring you. It's because I have slides I need to go through. And if I'm not always paying attention to the questions, please forgive me for that. So just a couple more minutes and then we will get started officially. But I guess while I'm here, everyone, if you want to just leave in the comments where you came from, how you found out about this event, just leave me a message letting me know a little bit more about my audience. Just make it a little bit more personal, add a bit of a personal touch to this disembodied voice that's going to be teaching you about in-vehicle networks and automotive cybersecurity today. Yep. Almost there. Sandy JN from India. Got it. Nice. Abdullah came in through LinkedIn. Always good to see the LinkedIn marketing is reaching its objectives. Right, how many viewers do we have in chat? Right now we have about 7 people. All right, that's pretty good. We're just about at the deadline to get started though. So in another minute or so I will be getting started. Maybe some more people will be joining. I probably won't be looking at the YouTube metrics during the presentation because I have notes in my presentation that I'll be looking at. So Canada, and I'm a computer science major, but I worked with some CAN systems before. Well, I would say that you are definitely one of the most intelligent individuals I've ever heard of, Abdulali. And software engineering experience with CAN experience is quite rare because in general people who like tinkering with cars also hate programming. I'm one of those people. So someone like Abdulali who has that dual experience with software engineering and CAN bus is someone that I personally look up to because my programming skills are not really there. But anyway, it is 1 o'clock. I will be switching over to the PowerPoint presentation and we will get started with the presentation. Okay, so official beginning. Welcome everyone to the next ASRG live webinar. This is an ASRG APAC event, not in the sense that you're not allowed to join if you're not in the APAC region, but the time slot for this presentation was selected to be easy for the East Asian Pacific region to join. We've had a bit of trouble joining in the other worldwide webinars throughout 2020 as a result of the fact that if it's at noon in Detroit time, it's 1 a.m. here in Japan, where I'm actually broadcasting from. So we wanted to make this accessible mainly to the APAC region, but of course, if you're from anywhere else in the world, you're just as welcome, and we're happy to have you. So today's lecture or webinar, or workshop I should call it, is Intro to InVehicle Network and Getting Hands-On with CAN. In this presentation, I'm going to be talking about what an in-vehicle network is. For any of you that aren't familiar, we're going to talk a little bit more in depth about the CAN protocol, CAN being short for Controller Area Network. It's the most common in-vehicle network technology in the world today, and is definitely the first place people kind of start to learn about automotive security specifically when they're starting their journey. And then we're going to have a majority of the time spent on hands-on CAN programs that are freely available for anyone to use. They're free to download, and they're quite useful, if I do say so myself. It's all open source software. So let's get started. So a quick introduction, just to give a face to the disembodied voice in the background. My name is Kamel. I'm an automotive cybersecurity architect at White Motion. White Motion is a subsidiary of the large Italian automotive supplier Marelli. Marelli is actually the joined entity that is the prior Magneti Marelli from Italy and the Japanese Tier 1 Calsonic Kansei. I've been on automotive security for about 3 years. I speak 3 languages, English, Arabic, and Japanese, and I've got experience as a trainer, consultant, speaker, and penetration tester throughout my time in the industry. I'm an active participant in ASRG, the SAE, the Auto ISAC, the Car Hacking Village, etc. I find that one of the most fun things about automotive security is the fact that there are a lot of opportunities to share it with other people. And so I'm hoping that today I'll have an opportunity to share my expertise with in-vehicle networks with you all. So what is an in-vehicle network? Simply put, it is a network designed for vehicles. Modern vehicles are filled with control units that we call ECUs, electronic control units. This diagram attempts to illustrate what I mean by an electronic control unit. You can see different nodes or microcontrollers inside a vehicle that are connected to one another and need to communicate. An in-vehicle network is a networking technology specifically designed for these smaller purpose-driven electronic control units that go inside vehicles. They're designed with specific purposes in mind. They need to have a lot of robustness and reliability, especially when you consider the fact that vehicles are very large objects that have people inside them that are moving very fast. There's a very strict safety requirement when it comes to approving an in-vehicle network for use in the industry. They usually have very strict timing requirements. This goes hand in hand with the safety aspect. They need to be able to meet specific data speeds and deadlines in order to make sure that the vehicle operates without any issues. And they're very simple. They're not quite as complicated as your wide area networks or your wireless transmission communications, so on and so forth, because they do have very limited scope of operation. So they're kind of optimized for those simple tasks. They're rather ubiquitous in modern vehicles. A lot of these standards or these technologies are actually included in industry standards, making them mandatory. Their inclusion is mandatory in vehicles all over the world. For example, the United States and most of Europe, there are standards that dictate that the CAN bus, which we'll be talking about later today, is used for diagnostics, for emissions, so on and so forth. And diagnostics and operation are 2 key areas where in-vehicle networks are used inside vehicles. But why is it important to study in-vehicle networks? If they're inside the vehicle, right, they're not connected to the outside, is it really that important from a security perspective? Well, the in-vehicle networks are technically the most automotive part of automotive cybersecurity. Much of automotive security can have parallels drawn to traditional cybersecurity, networking security, cloud security, etc., because the car is now, the modern vehicle is connected to the outside world. But once you get inside the vehicle, the part that makes an automotive security assessment different is really the automotive specific parts. You're not likely to find an in-vehicle network technology anywhere else. It's possible, of course. They're not exclusively used in the automotive industry. For example, I've seen washing machines that have a CAN bus, or a lot of robotics and industrial systems will actually use CAN bus, for example, because it does the job very, very nicely, but it was originally intended for use in automotive. And because they're crucial to the vehicle operation, anyone hoping to explore the full breadth of an automotive security situation needs to understand how these automotive in-vehicle networks play into the operation of a vehicle. For example, what's shown up here, an X-by-wire system. An X-by-wire system is a system in which driving or steering or braking is directly controlled by data from an in-vehicle network. And so this is a situation in which understanding of that network is critical to understanding the cybersecurity posture of that vehicle. Also for diagnostics, diagnostics are used for things like rewriting the firmware on an ECU. If you have a chip inside a vehicle that needs to be updated, oftentimes an in-vehicle network is used to deliver that update. And so there are diagnostic protocols built on top of these in-vehicle network technologies that are commonly used to achieve that goal. So, what in-vehicle network technologies are in use? What exists on the industry market today, and where are they used? So there are different networks for different tasks. These are going to be split up based on their bandwidth or their network topology architecture or so on and so forth, or cost even, right? So different technologies will have different use cases. Automotive Ethernet is a very new one. It's a very advanced in-vehicle network technology, and it is quite the controversial one. It has very high bandwidth. It's very similar to old school Ethernet, quote unquote, but it allows the automotive components to communicate with one another at very high speeds. So you'd see something like Ethernet in a situation where you have a lot of data that needs to be processed, for example, from a camera, right? If a camera is sending high quality image data for image analysis inside an ECU, it's likely going to be connected by Ethernet or some other high bandwidth automotive technology. Ethernet's not the only high bandwidth one, but I just included a few examples here today. The second one I want to talk about is kind of the other end of the spectrum, LIN, Local Interconnect Network. LIN is very low bandwidth and it doesn't have the same full suite of security and robustness features that another network technology like CAN might have, which is why it's only used in non-safety critical systems. This would be something like, I don't know, maybe rolling down your windows or adjusting the positioning of your seat or maybe your windshield wipers. It depends from manufacturer to manufacturer how these networks are used, but the basic profile of LIN is that it is a simple low bandwidth network that's very, very cheap to implement. And it is an open source standard, I do believe. And then finally is CAN, kind of the star of the show, everyone's favorite in-vehicle network. It is the most common in-vehicle network in use today, and it is very easily accessible. There are a lot of free tools for learning CAN bus and even just for operating on an actual CAN bus in the industry. If you actually need to operate with a CAN bus, there are a lot of free software and very inexpensive hardware modules available that will let you get involved with an in-vehicle network. And so the next step in this presentation is going to be a quick crash course on CAN. So before anything else, I just want to make sure there are no issues with the audio. If anyone wants to drop a comment in, I'll be checking that in just a second. But if not, then I'll happily continue. So CAN bus is a bus topology network. And it is multi-master. What this means in real life is that all the nodes on a CAN network are connected to the same bus, right? This bus is made up of two wires, right? It is a dual wire network, and it uses differential signaling, which I have there at the bottom, right over here. And I'll explain this a little bit in a second. It uses 8 byte payloads per frame. Keep in mind, there are lots of different versions of CAN, but the most common one is what we'll call high-speed CAN. There is a ISO 11898. There's a very long ISO standard that's the specific designation for high-speed CAN, but in general, we're just going to be talking about CAN in the sense that we're using high-speed CAN, right? So 8 byte payloads per frame, and it supports theoretical data rates of up to 1 megabit per second. There are certain physical limitations in place, however, that make 1 megabit per second not very practical. And so most often you'll find a CAN network operating at 500 kilobits per second instead. This is one of the more common speeds, but there are slower speeds such as 250 and 125. CAN bus is a very robust network protocol. It has built-in error management and error detection in the form of a CRC, and it has an arbitration-based priority system that allows more important messages to be received and processed on the bus faster than lower priority, less important messages. The arbitration process is its own lecture in and of itself, so we won't be going too in depth into there, but you can think of arbitration IDs as kind of identifiers for any given payload and what is inside that payload. It's not a source address and it's not a destination address, so there's sometimes some confusion for those of you coming from a traditional networking position. You may be a little bit confused if there's no source or destination address in CAN, and that has to do with the fact that it uses a bus topology and is a multi-master protocol. All of the nodes reside on the same bus, all of them communicate on the same two wires, and all of the nodes can see every message that gets transmitted on the bus, and any node is allowed to send at its own leisure. It doesn't need to wait for a master node to poll it for data. So we already talked about the theoretical maximum speed of CAN bus, and let's just take a second to talk about the dual wire differential signaling. So differential signaling is a technique not only used in CAN, but also in Ethernet, FlexRay, and some other networking technologies as well. Basically, if you have two wires that are very closely intertwined, and the voltage measuring on either end of this system is done by measuring the difference in the voltage between these two wires, you introduce a system that is much more resilient to electromagnetic interference, or EMI. Right? The EMI that just exists in the world. A vehicle has a lot of different electronic components, a lot of different power cords, etc., moving throughout the vehicle. So a lot of times there's a lot of electromagnetic noise in the air, and this is just something you have to live with. You can't quite get rid of this. This is part of the universe. But because of the way differential signaling works, because one bus line drives up and the other one drives down, the difference should always stay the same as long as both wires are impacted by the EMI equally. This is quite an interesting topic, and I could talk more about this for another 30 minutes or so, but I do have a deadline I have to keep, so I'm going to be moving on from here, but I'm happy to answer any questions, of course, towards the end. So this is the actual fun part. We're going to use a open source CAN library called CANutils. This is at the moment only available through Linux. So if you have a Linux machine handy, you're welcome to follow along. I will be switching my screen over to a virtual machine in just a second. But CANutils is an open source free CAN tool package for Linux that operates on an underlying software stack called SocketCAN. SocketCAN is a very important piece of software that was added to the Linux kernel by the Volkswagen Group, I believe, that allowed CAN buses to be operated on in the same way traditional network sockets are. This did a lot for the state of the industry because it made tools easier to use and just better overall. Once again, I could go into detail about this, but we do have to keep going because the fun part is next. We actually get to see the tools in action, and you'll actually get to see what working on a CAN bus looks like. But CANutils offers functionality to read data from a CAN bus, send data onto a CAN bus, log CAN bus data, reverse engineer CAN bus data. There are better tools, of course, if you pay a lot of money, but for a free software, it does the job pretty well. You can replay logged CAN data onto a CAN bus, so you can capture a packet capture, a log of CAN data, and then replay it sequentially onto the CAN bus for replay attacks, so on and so forth. And you can generate lots of CAN data. You have the option to produce random data, incremental data, so on and so forth. You can also create virtual CAN buses. This isn't a feature of CANutils particularly. This is actually a feature of SocketCAN, but these two, the virtual CAN bus and SocketCAN and CANutils, kind of all work together in perfect harmony. And they're incredibly easy to install and even easier to use, which I will hopefully be showing you in the next couple of minutes. On Debian platforms, it's literally just run one command and you have access to this entire suite of software tools. There's no Git repository cloning and manually building and none of that. Nothing to worry about. Okay, so I'm going to switch over to the virtual machine, and you guys will be able to watch me as I perform some very basic Linux virtual CAN bus functionalities. Of course, if you have any questions during this time, please write them down. I'll be happy to address them when we get the opportunity. Give me 1 second while I disable the output, just while I switch my monitor. Here, let's turn this on. Over here, let's go back here. Oh, well, I've put myself in a weird position. Okay. Okay, there we go. There we go. So you should be able to see my my virtual machine now. Oh, that's not correct. Nope. Okay. Come on. There we go. There we go. Okay, wonderful. So here we are in a Kali Linux virtual machine. I have a lot of extra programs installed on this machine because I use it quite a bit, but nothing that I have installed here is, you know, prematurely necessary for CANutils. Most of the stuff you need is already available. I'm going to run through the command to install CANutils very briefly, just so that you know how to install it if you don't have it installed on your machine. It's simply sudo apt get install can-utils. If you're running Kali Linux or Ubuntu or a similar Debian-based distribution, this is usually good enough. Just got to put my password in, of course, and obviously I already have the software installed, so nothing happens. But if you did run this on your own machine for the first time, you would then have access to CANutils. So with CANutils, we have a couple of different tools. We have CANdump, we have CANsend, we have CANgen, we have CANreplay, I think, or is it CANplayer? I think it's CANplayer. I get confused sometimes with the syntax because they all sound kind of the same. But anyway, there are a lot of tools that come with this, and we're going to walk through using them one by one in today's workshop. So the first step, of course, is we need to create a virtual CAN bus. So if I go ahead and run the command ip-link, you can see I have two interfaces, two network interfaces. I have an Ethernet one and I have my loopback one. We want to add one. We want to add a virtual CAN bus. And remember, Socket CAN treats CAN buses the same way that the kernel treats traditional network interfaces. So we're going to do this with modprobe. So sudo modprobe vcan, right? Vcan here stands for virtual CAN bus, right? Go ahead and run that. Sudo ip-link add, dev stands for device, vcan0. This is the name of our interface. You can name this whatever you like, but I'm going to keep it vcan0 just for simplicity's sake. And then I'm going to specify the type of interface I want to add. So type vcan. Enter. And so now if I run this command again, ip-link, right, we're going to now see we have a new interface named vcan0, right? It's a vcan0, right? There's some extra information here, but, you know, highlighted in big red letters is the word down. And you can see here it is type CAN, right? Very cool, very cool. But we don't want it to be down anymore. We want it to be up so that we can actually start using it. So sudo ip-link set up vcan0. And you can run ip-link once again, just to double check. And as we can see, it is no longer down. Well, it's kind of unknown is what it says here, but don't worry about it. It's working fine. Please take my word for it. So this is how you would make your own virtual CAN bus. It's honestly as easy as pie. It is incredibly easy to do if you don't have any CAN bus hardware. This open source software makes it very easy to learn about CAN bus without needing to buy expensive CAN hardware. There's cheap CAN hardware, but even then, you know, if you don't want to make the 50, 60 US dollars investment to buy a piece of CAN equipment, then you have the option of learning on a virtual CAN bus and eventually switching over to hardware-based modules instead. One thing I do want to mention is that this command here that we used to set up the CAN bus, this is the same you would use for a physical CAN bus. You can use these software tools with a virtual CAN bus or with a real CAN hardware that has Socket CAN support. A lot of devices come with built-in Socket CAN support, as in you literally plug it in and you're good to go. Other devices, you might have to do some tweaking, some adjustments to the software to get it to work, but there's a whole plethora of freely available software that works with these different devices to get them to work. Although we're not using hardware today, please just keep in mind that everything I'm going to show you from here on out is possible with hardware as well as with this virtual CAN bus. So I'm going to go ahead and clear my screen. And the first thing we're going to do is look at some CAN data. So let's go ahead and run CANdump vcan0. CANdump is a program that outputs CAN bus data to the standard output, or in layman's terms, your screen. Your monitor, your terminal, will then show CAN data. So I'm going to hit this, and nothing really happens. And there's a good reason for this. It's because there's no processes sending CAN data onto the virtual CAN interface. But we can change that, because in Socket CAN, we also have the ability to send CAN data. So I'm going to open up another terminal window here. I'm going to say CANgen vcan0. We'll talk a little bit more about what CANgen does specifically, but if you run it like this with no additional options, nothing else, nothing fancy, just hit enter, it's going to start generating random CAN data. And if I come over here, you can see that all of this data has started to appear. So let's pause for a quick second. I'm going to stop the transmission, right? And we're going to talk about what exactly we're looking at here. So CANdump on vcan0, we've specified this interface, has started to show us the CAN data that has been generated by the CANgen process. Here you can see the name of the interface. This is the arbitration ID associated with this CAN frame, right? Every CAN frame can have up to 8 bytes of data, right? And you can see here the length of that data encoded in a field called the data length code. This is the DLC, right? Not downloadable content for any of you people who play video games and have to continuously buy new content for your game. The DLC here stands for data length code. So this tells you how much data is in your packet, right? It'll be up to 8 because that's the physical limit on CAN. The arbitration ID is used to identify what type of real-world information is stored within this data. Because obviously inside a car, if you look at the electrical signals and you convert them into hexadecimal, they will look something like this. But to the ECUs actually processing this data and using it to operate the vehicle, there's hidden meaning behind all of this data. This has to do with CAN signals and database types, etc. We can't go all the way into that today because we do have some more key features we have to talk about. But knowing that this hexadecimal data gets translated when it's received by an ECU is an important step in learning how to reverse engineer CAN data. So there's not that much information that we can see here due to the fact that there's no timing information, right? There's no, how should I say, you can't see if like the message was transmitted or received. There are options for CANdump that I will very briefly take a quick look at. If you use the man command for the manual of CANdump, you can actually see all of the options available with CANdump that may be useful in your use of it, right? So some of the options that I find very useful are the -n, the count. So this means that you want the program to stop automatically after it's grabbed a certain amount of data. This is incredibly useful when you're using something like logging data, because CANdump can be used to log data as well. So if, say, you want to make logs of a fixed size and then restart it each time so that you have, little archives of a fixed size of CAN frames that makes it easier to look through them later, you can use the count option to make something like that work, right? There's also filtering, and there's extra message info, RxTX, so on and so forth. You can see if it's a extended message or not. You can see if it's been sent by your device or if it's only been received. Sometimes this is helpful in just getting more context as to what's going on in a CAN log. You may enable this option when you're logging data. It's pretty helpful. And then, of course, the real important part is the filtering, right? So comma-separated filters can be specified for each CAN interface. The filtering is kind of complicated, so I won't go through it from start to finish today, but you have the option of actually filtering out what CAN data you view. This is important because while in this example, we didn't have that much CAN data, so it wasn't really a huge deal, we could see all of it just fine. In an actual vehicle, you may have 3, 4, 5, 6, 7, 8 different ECUs on a CAN bus, all transmitting data at the same time and very, very quickly. So this means the CAN bus can get very noisy. You have a lot of data that's flying back and forth, and you're not interested in most of it. You're just interested in 1 or 2 arbitration IDs. Well, obviously, you have to have a way to filter this huge torrent of CAN bus data into something that you're actually looking for. You can narrow down the CAN messages that you're hoping to reverse engineer, that you're hoping to identify, that you're hoping to observe and understand their operation. You can do that with the filters in CANdump. And like I said, it's a little bit difficult. There's some logic you have to know with the way the filters work. They use a mask and a base ID. But for now, we're going to carry on. I have about 20 minutes left to get through the rest of the CANdump or the CANutils package, and I want to make sure I give every bit of the software its due right. So obviously, this was really cool, right? We were able to send a lot of random CAN data, but what if I don't want to send random CAN data? I want to send a specific message. So let's give that a shot. So let's go ahead and say CANdump vcan0 once again. And we're not going to use CanGen because this is kind of chaotic. We're going to, let me actually, can I detach this? Let me just make another terminal, and we'll try and do some balancing so that we can actually have our view window here, and this is our sending window, right? Our sending terminal. So I'm going to say, let's say I want to send one CAN message. I want to send CAN message with the arbitration ID 555. Right? So there's a command for that in CANutils. Can send, right? It's pretty simple. It does exactly what it sounds like it does. vcan0, right? Specify your CAN interface to make sure you're sending on the correct CAN bus. 555. There is a delimiter, which is the hashtag here, right? And we can send any payload we want up to 8 bytes. So popular options for this, for demo purposes, include dead beef code cafe, right? It's just a silly sentence that you can write using the hexadecimal numbers, right? 0 through 9 and then A through F. So if I hit enter here, we will see in real time that this message gets transmitted onto this virtual CAN bus. By the way, the virtual CAN bus behaves almost exactly the same as a real CAN bus, right? The only thing is that you're lacking the physical actual hardware components. And so it's not a perfect one-to-one match to how things would behave on a CAN bus, because there are things like priority and collisions and so on and so forth that get handled a little bit differently in virtualization. But if I hit enter, you'll see we can see here, right? vcan0 555 data length code is 8. Dead beef code cafe. It's exactly the same message that I sent from this window. So if you're ever plugged into a car, you have your CAN hardware and you're using open source CAN software, and you just want to see what would happen. Maybe if I send this message with this payload instead of this payload, because the car is sending this message with all zeros, what if I send all Fs instead, right? See what happens. You just want to see what happens? Go ahead and send a message using CANsend, right? Great way to do it. Very easy. Easiest way to send one CAN message. You can use these software tools for more advanced programs if you do things like create scripts to actually automate the use of these command line tools, right? But that's a little bit more advanced and not something I can actually go into today. But it is very easy, right? At the end of the day, it's as easy as writing a simple bash script and using the CANutils tools in that script. So you can also do things like delimit your data with a period. This is more useful when you're actually using the CANutils commands inside a script. Sometimes you need to be able to insert variables into your payload, and this helps with that. But periods can be used to kind of separate, delimit between bytes in your CAN frame. Just a tiny bit of trivia, but it is one that is worth remembering for the future, in my humble opinion, of course. So what can we show next? We've shown how to see data in the window with CANdump, and we've shown how to send our own data, and we showed a little bit of how to generate a bunch of random data. CanGen is a tool that allows you to generate lots of volume of CAN data, but it doesn't always have to be entirely random. You can have CanGen be used if we actually, let's take a look at the man page for CanGen real quick, right? You have a couple of options. There are different modes here. This I option here allows you to select the CAN generation mode. So the modes are listed here. R is random values. This is the default, right? If I run this with no other options, it just defaults everything. I is increment values, and hex value is to fix a certain value. Now you can apply these modes to the data length code, the arbitration ID, and the payload. So you could send messages on one arbitration ID and have the payload and the data length code be random. Or you can mix and match, right? So for example, if I go ahead and do it again, CANgen vcan0, right? And we come back here to our window, everything is randomized. The arbitration ID is randomized, the data length code is randomized, you have a couple zeros in here, and the data bytes themselves are randomized. Pause that. But if we come back here and we instead try and use this with the, let's try and set it so that the arbitration ID is the same every time, but the payload increments starting from 0. Let's go ahead and say CANgen vcan0. I believe it's going to be dash the ID. I select. Here we go. So dash I is for identifier. I'm going to say 555. Dash D, right, capital D, is going to be R. And then dash L is going to be 8. So what this is going to do is that it's going to start generating CAN data on the arbitration ID 555. This is never going to change. The length is always going to be 8, but the data bytes themselves are going to be random. Maybe this is useful. Maybe you have a particular CAN bus address and you're just trying to fuzz that arbitration ID. You're trying to throw as much random data as possible at it just to see what happens, just to see if the car behaves strangely, which is something you may end up doing someday on an actual vehicle assessment. So we're going to come here, CAN-vcan0. I'm going to fire this off, and you're going to see that it's a little bit different than before. The message always comes out as 555, always has a message length of 8, but the data bytes themselves are randomized a little bit. This is pretty cool, right? But obviously, if you are looking at an actual car, right, looking at the CAN data like this can be kind of miserable because it's showing you every single message one after the other in a sequential order. If you don't have any filters, your terminal is going to end up filling up very quickly, and it's not really great for doing real-time analysis. It's not really great for what we call reverse engineering. Well, luckily, we have another tool in CANutils specifically made for viewing CAN data with additional information for reverse engineering. And I'm going to talk about that in just a second. This tool is called CANsniffer. So CANsniffer also displays data in the terminal, but it does so in a very different way. Instead of showing every CAN frame sequentially, CANsniffer actually shows you only the most recent value of any given CAN frame based on arbitration ID. I'll show you what that means. So let's go ahead and say CANsniffer -C. -C adds some color to the output. This is important. vcan0, right? We'll go ahead and hit enter, and it's waiting for data. We don't have any data yet. We're going to go ahead and run the good old-fashioned CANgen vcan0, the randomized one, right? And it looks almost exactly the same, but there's a couple of differences here, right? We'll talk about that in just a second. So I'm going to hit pause, and oh, it's all disappearing now. I forgot to use the other one, the -T0. This makes it so that there's no timeout for the data, so that it stays on the screen the whole time. So let's just run this again real quick. Sorry about that. I made a little mistake there. Forgot about the timeout on CANsniffer by default. So what's going on here is you can see the data, and you can see a lot of the same data that you saw with CANdump, but there's a bit of a difference. For example, each ID here is once again kind of separated, and you see this 999999, right? Like this full nines over here. What does this mean? This means that this is the first time that this message has arrived on the bus. But if, for example, I were to go ahead and use a CANsend, right? CANsend vcan0, and then we have 5555 or 555, and then we say 111111, right? I send this message, and it appears here, right? Now, if I were to change this payload, make it 2, you're going to notice something interesting on the CANsniffer terminal. That 2 gets highlighted in red, and you get to see the offset. This is how much time passed between the last message being sent and the current message. This is about, it's in milliseconds, right? So this is going to be about 10 seconds. I took 10 seconds. I'm pretty slow, right? So if I do this again, let's make this a 3, we're going to see this highlights in red, and there was 20 seconds between me sending the previous message and this message. So this highlighting feature is actually incredibly important. It's helpful because sometimes you have a single CAN frame that you're watching, and you want to see which bytes change when the car performs certain actions. Maybe you want to see, all right, which byte changes when I turn on the turn signal? Which byte changes when I unlock the door? So on and so forth. There are a lot of these discrete, real-world things that are mapped to CAN data. And finding out what real-world things are connected to what arbitration ID, which byte inside that arbitration ID, that is the CAN bus reverse engineering process. That's how, if you're working on an unknown vehicle type, you learn what the different bytes on the bus mean. Which, okay, this arbitration ID is related to steering, this arbitration ID is related to braking, this arbitration ID is related to speed, so on and so forth. Eventually, you can build a full profile of this vehicle's CAN bus and use that to, well, there are a lot of cool things you can do with it. You can make customized dashboards, etc. But there are also some very dangerous things you can do, especially on vehicles that don't have security implemented on the CAN bus. There's the possibility that you break something or trick the vehicle into thinking it's going way faster than it is. And if it has an automatic braking system, you might engage it. There's a lot, there's really an endless amount of possibilities based on how much care was put into the programming of the ECUs. Obviously, you're not likely to accidentally rewrite the firmware on a vehicle because that uses very specific diagnostic protocols to accomplish, but it is, worth noting anyway. So the next thing I want to show is how to actually log data using CANutils. So let's go ahead and back out of CANsniffer. I'm going to clear this terminal, and we're going to be using CANdump once again. So CANdump vcan0, right? Same as before, but this time I'm going to add a -L here. Okay, this -L, well, actually, let me really quickly, let me just make a directory so that we can safely create files without ruining anything on my computer. I'm saying dir ASRG CAN, CD ASRG CAN. Here we go, right? Nothing in here, perfectly new folder. And we're going to go ahead and say CANdump -L, my first, wait, no, you can't name it if you use the -L. You can name it. All right, sorry, I got ahead of myself. Okay, vcan0, right? This is all I'm going to do. I'm going to hit enter. Disabled standard output while logging, enabling log file, CANdump 2021. This is basically the date and the time. And it's opened a log file, and now this process is waiting and just grabbing all the CAN data and storing it into this log file. So if we come back here and we do this, the CANgen command where we were sending all of this information, right, only on the 555 line, we're going to make, instead of data random, let's actually set it to increment because I didn't show that. Here, let's say I'm going to hit enter, right? So now you can't see it, but take my word for it. This process is sending CAN data, and this process is receiving that CAN data and turning it into a log. If I come here and I stop, and I come here and I stop, right? We can then check ls. Oh, hey, we have a log file now, right? List all the files in this folder. We have this CANdump log file. If we go ahead and say word count -L, this is a program, it's a Linux command to check how many lines are in a file. We can actually check how many messages we captured. Oh, I captured 70 CAN messages. Well, that's pretty cool, I would say. What's inside those CAN messages? Great question. Well, let's think back to what exactly I did. I used a CANgen command with the arbitration ID set to 555, the data set to increment, and the length fixed to 8. So I'm going to assume that this CANgen process sent out the data 0, 1, 2, 3, 4, 5, 6 until it had reached 70 messages. That's just the coincidence when I happen to stop the process. How are we going to actually see that? Well, you can do that a couple of ways. You can say cat CANdump, right? We can actually just look at this in the terminal through the cat command, or we could replay it back onto the bus, which I think would be a little bit more interesting. I hope you guys agree. So let's go ahead and do that. To clear this, I'm going to come here, I'm going to say cd ASRG, and once again, we have access to that CAN command, or that CAN log file. We're going to come here, and we're going to say CANdump CAN0. Nothing special, right? Oh, oops, sorry, not CAN0, vcan0. I forget that I'm on a virtual campus. So here we are. We're dumping vcan0, and I'm going to come here and say CAN player. I believe it's CAN player. Yep. -I, capital I, for the input file, and I'm going to select can dump 2020 02 da, 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 right? This is the standard naming convention that can dump will use by default when you use the logging command. And if I press enter here, we're going to see that all of that can data that we generated in the beginning with the cangen command that we then saved into that log file is now being spat out back onto the bus in exactly the same order and exactly the same timing, right? Every message has a fixed amount of time between it, right? It stopped at 45. This is 45 hex, by the way, not 45 decimal. So this is about 70. This is 70 messages worth of can data. It's not that much, but it's pretty good. You should get the idea now, though, that if you wanted to record something happening on the CAN bus, you know how to do that now. You can use the can dump -L feature, right? Can dump -L. This is how you would record data on the CAN bus. If you then wanted to replay that recorded data, well, now you know how to do that. You have CAN player, and you can just take that log and go ahead and shoot it out there. But what if you didn't want to name your logs, can dump 2021 02 da, da, da. This is kind of hard to remember, right? Sometimes you want to pick the name of the log, and it's a pretty important thing to know how to do. You can do it, but I want to actually, let me go ahead and cat this file. Like, I have just a little bit more time. I want to show this, so this is important. You can see that the data here looks a little bit different from how it looks in regular can dump. If you remember, when we ran can dump, you didn't have this timing information, right? This is an absolute timestamp. You have, instead of having them be delimitered by a space, the data bytes and the arbitration ID look more similar to what you see in can send. This is done intentionally, actually. This is done so that the logging format is easier to read from a machine's perspective, but the basic output format is easier to read from a human being's perspective. So let me just go ahead and clear this. And we're going to go ahead and use can dump with a special command -L for log format vcan0. And I'm going to go ahead and I'm going to just hit cangen vcan0. Bam. So now you can see we're seeing randomized can data like we expect from cangen vcan0, but now it's in the log format instead of the regular format. Now this is useful because we can use this to create customized logs, and this is through a Linux feature. So if I say can dump -L vcan0 and I direct this output to my log.log, right, it'll do the same thing. And now once again, you can't see the output, but it's actually creating a log file called mylog.log. So when I stop this and I stop this, we hit ls, you can see I have a file called mylog.log. I'm sorry, I'm kind of rushing through this because I do need to go back to the question and answer section in just a second. So that is how you would create a customized log file with a customized file name. And this makes it much easier, especially if you're including these commands into programs that you make. So if you'll excuse me, we have to get to the question and answer section. So I'm going to now switch my screen over to the YouTube live stream. I believe if we have any questions here in the chat, I will be happy to answer them. What do we have? All right, any questions at all? This will be recorded, Thinkers Academy. It will be recorded on the ASRG YouTube channel. So if you're not, it should be available afterwards for anyone to review. Hello from Stuttgart. Welcome, welcome. It's great to have you. It's great to have you. This is going towards more interesting, I'm sure. Hopefully we will get the recorded one too. Yes, this will be recorded. So the purpose of this lecture is so that anyone hoping to learn these techniques has the opportunity to learn them. I'm here to help everyone understand. Obviously, not everyone wants to have to run to keep up with a video. With a live course, it's sometimes more easy to look back at it later and actually understand, what exactly happened when you're just trying to pay attention during the live session. So we totally understand that this lecture should be available on the ASRG YouTube channel afterwards. So I do have another 5 minutes just allocated for the question and answers. If anyone has any questions, of course, please, by all means, just drop them in the chat. I'll be happy to answer them live. I'd like to think this is a pretty good opportunity to get a live question and answer session with well, just me. I'm nothing special, but I'm a guy who's doing this stuff. If not, well, we are still about 15 minutes from the deadline. Were there questions being submitted anywhere else? I'm the only one running this thing, and I don't see any questions elsewhere. Yeah, it doesn't look like there are any. That is perfectly fine. If nobody has any questions they want to ask now, then obviously that's great. I'll be happy to answer any questions you have later through email, of course. But if that's the case, I think we can actually finish things off a little bit early. So I want to give a special thank you and a shout out to the Tokyo cybersecurity community. They are a group here in Tokyo. They helped a lot with the marketing, and they shared this. They basically helped promote this event within their network here in Japan. もし日本語しか話せない人がいれば、プレゼンテーションが英語ですみませんでした。気にしていなかったけど、もちろん質問などがあれば、ぜひ私にイメールを送ってください。For those of you English speakers, non-Japanese speakers, I wanted to make sure any Japanese people in the audience were aware that I'd be happy to answer any of their questions. If they just send me an email, I'd be happy to provide any advice or guidance that I can based on either the contents of this lecture or I'm always happy to chat in any other capacity as well. My contact information is there on the screen. I don't bite. Don't be shy. Go ahead and send me an email. I'm happy to help as much as I can. So of course, once again, thank you to the ASRG. Thank you to White Motion, my employer, for allowing me to give this presentation while I'm on the clock. This is something White Motion encourages me to do, is share with the community. Oh, excuse me. We have some questions. We have JP asking if I have fuzzed my own car. So at the moment, I live in Tokyo, Japan. I don't actually have a car right now, but I have fuzzed my dad's car. Don't tell him I did that, but I may have played around with my father's car a little bit, and I reverse engineered the functionality of his rear view camera, which was quite fun. But Abdullah Ali asks, do you think this might work on an Ubuntu native in Windows 10? Ubuntu is Debian based, so I believe it should work just fine. So the thing about virtual machines is that if you want to use a real CAN bus, of course, you have to make sure you're passing the USB device from your host operating system to your virtual machine. And from there, obviously it should work, but you might have some performance downgrade as opposed to using a bare metal Linux machine. But I believe the Ubuntu native in Windows 10 shouldn't be a problem because Ubuntu is still a Debian-based operating system. So give it a shot. And if that doesn't work, of course, there are very low cost alternatives. Like a Raspberry Pi can be outfitted with hardware to do this kind of CAN bus work. It's not that cost prohibitive, I'd like to think. So anyway, I'm out of clever things to say. So if anyone has any last minute questions, I'll happily answer. But if not, then I will be signing off a little bit early. But once again, thank you so much to everyone who helped make this happen. Keep up with ASRG on our Facebook and LinkedIn pages and the website asrg.io. We're doing our best to make sure that automotive cybersecurity is accessible to the entire world. It's for the sake of our futures, and it's more than just jobs for us, right? For us, this is about making sure that our vehicles are secure and protected from the threat of malicious hackers, be they advanced persistent threats or amateur script kiddies just trying to see a car crash. Right? You never know who's out there in the cybersecurity world. Thank and greetings from Munich. Oh no, thank you for coming. I appreciate you, gents. Really, my pleasure to have you today. So, anyway, thank you all so much, and we will see you in the next ASRG webinar. Here on the ASRG YouTube channel. Thank you so much, and take care.